Welcome to the first in a short series of videos demonstrating the performance and capabilities of the Synopsys latest DesignWare 56 gig Ethernet PHY IP in the TSMC 7nm FinFET technology. Let's start with the capture of transmitter PAM4i diagram at the 53.125 gigabits per second data rate, which is required in today's 400 gig plus hyperscale data centers. Here we have the Synopsys test board with the 7nm 56 gig Ethernet PHY test chip inside a 70 GHz socket, as well as an FPGA for simple register control and communication with the test chip. Here is the captured PAM4i. The three high signal quality PAM4i's show a good symmetry between the top and bottom eyes, demonstrating the good linearity of the transmit output driver. Next is a check of the receiver jitter and interference tolerance. This is our receiver performance test bench consisting of a Jaybird supplying the test signal to the transmitter replica channel, then through a Wild River ISI 25-inch PCB channel, then to the receiver device under test. The total channel loss is more than 30 dB from test point 0 to test point 5, which is what is required by the 802.3 CD jitter tolerance and interference tolerance test 2 procedures. The 802.3 CD jitter tolerance spec compliance mask is shown in black. Sinusoidal jitter is injected on the test signal at different frequencies and swept in amplitudes. Each test point is shown in green and the amplitude is swept up until the target bit error rate is achieved. The resulting jitter tolerance performance curve is well above the specification compliance mask across all frequencies of the injected sinusoidal jitter. The interference tolerance test stresses the receiver in the presence of noise or crosstalk. The horizontal line is the bit error rate of 1 to the minus 3 limit, and the vertical line is 1.6 millivolt RMS of injected noise for a channel operating margin of 3 dB. As the measurement crosses the vertical line, the bit error rate is 1 to the minus 8, 5 orders of magnitude below the spec target of 1 to the minus 3. A bit error rate of 1 to the minus 3 does not occur until beyond 3.25 millivolt RMS, or double the prescribed noise in the 802.3 specification interference tolerance test. Now let's test the combined performance of the Synopsys 56 gig Ethernet transmitter and receiver in loopback. We will start with 53.125 gigabits per second PRBS31 PAM4 transmission over a 23.5 dB loss channel, die-pad to die-pad. On the left is the 7nm 56 gig Ethernet test board, and its transmitter and receiver ports are connected to a 15.5-inch test channel on the Wild River ISI board. The 56 gig Ethernet test board evaluation platform also includes a graphical user interface for controlling the PHY and accessing in-PHY diagnostics and performance metrics. On the left is where the data rate, pattern, and amount of transmitter equalization is set. After hitting apply, the PHY receiver will adapt to the channel and incoming data. In the middle, diagnostic plots in both histogram and scatterplot formats are shown for the analog front-end output and for the decision feedback equalizer output. On the right are plots of the feed-forward equalizer coefficients and a non-destructive two-dimensional PAM4i monitor. With this medium reach 23.5 dB total channel loss, the recovered PAM4i's are wide open and the user interface is registering 0-bit errors. In a time-lapse video capture, here you can see that more than 3 trillion 53.125 gigabit per second PRBS31 bits were sent, and the raw bit error rate is 9.9 to the minus 13 with a confidence level of 95%. Now let's test across a longer channel. The 56 gig Ethernet test board and its transmitter and receiver ports are connected to a 31-inch channel on the Wild River ISI board. The total loss, bump to bump, is 40.5 dB. Once again, we configure the transmitter data rate, pattern, and equalization. Again, we can see the diagnostic plots of the recovered signal at the analog front-end output and the DSP outputs. The two-dimensional non-destructive eye diagram shows open eyes. However, as expected for these higher loss channels, bit errors will occur with PAM4 due to the lower signal-to-noise ratios and higher sensitivity to the non-idealities like jitter and ISI. Looking at the repeated diagnostic and bit error rate captures, you can see that the receiver DSP is able to open up the PAM4Is and that the raw bit error rate is in the order of 3 times 10 to the power of -6. The 50 gig Ethernet standard was designed with this raw level of performance in mind. That is why a Reed-Solomon forward error correction or RSFEC scheme is included. Let's enable the RSFEC and observe the post-FEC bit error rate. After resyncing the pattern matchers, we can see that the post-FEC bit error rate is 0. To prove that it is working, we will now inject 10 errors in the FEC encoding and confirm that exactly 10 FEC errors are observed at the receiver. With repeated diagnostic and post-FEC bit error rate captures, you can see that the receiver DSP is able to maintain open PAM4Is and the post-FEC raw bit error rate remains 0 over the 1.5 minutes of this video. At 53.125 gigabits per second, that is over 4 trillion transmitted bits error-free. This concludes our demonstration of the Synopsys DesignWare 56 gig Ethernet PHY IP in the TSMC 7nm FinFET technology, meeting and exceeding electrical specifications. The PHY is available today. Thank you for watching.